Everyone, we're going to move right along to phase 3, factoring quadratic expressions. And so I believe I gotta count, 6 examples. I want to write that one down so that you know what you guys are getting yourselves into. We have 6 examples today, plus 6 practice problems for you to do towards the end of the video after the lesson today. Okay, so this is phase 3. I'm under the assumption that you have watched my previous phases of factoring, phase 1 and phase 2, both parts, part 1 and part 2, and so that's why you are here. We're still dealing with quadratic expressions where the coefficient is 1 in front of the x squared, so it's not too complicated. It'll get a little bit more complicated on the next phases, especially phase 4 and phase 5. Okay. We are going to deal with 2 special cases, and that's perfect squares and differences of squares. So let's just get already started with example number 1 here. Still a little bit sick, but that is okay. I emphasize that there's a 1 in front of the x squared, but most problems will just look like this. It's going to be pretty much the same thing as how we've done it in the previous phase, where if there's a 1 in front of the x squared, well, what 2 numbers multiply to 16? Well, we have 8 times 2, that's good, but it does not add up to this middle term 8 here. So we're probably not going to use 8 times 2. We're probably are going to use 4 and 4, because positive 4 times positive 4 is 16. And when you add them together, it's going to be also positive 8. And so just like from the last phase, we're going to write this as 2 factors multiplied together. So it's going to be x and x. And because they're both positive, we're going to go x plus 4 and then x plus 4. Unlike the previous phase, though, for this one, you see that these 2 are the same factors. When you have 2 of the same parentheses, the same factors, you're going to put this as x plus 4 squared, and you have completely factored this expression. This will be your final answer for example number 1. Okay, these 2 of the same thing like that. When you have this is called perfect square. Okay, and the reason why we call it perfect square is one reason why is because if you go back to geometry and find out the area of a square, well, the area of a square is side times side, or s squared, or x squared. It's up to you what your teacher gave you the variable for, but pretty much it's side times side. You know, the same side times the same side, because all of those sides are all equal. And hence, I hope you guys can see that we pretty much have 2 of the same factors or parentheses. We're really going side times side over here, or s squared or x squared. And so this is one reason why it's called a perfect square. Okay, x plus 4 quantity squared. Okay, let's move on to the next 2 examples, and then after that we'll get into some a little new material. Examples number 2 and 3, I'll put them together like this. Okay, let's start with this one first. Now there's a 1 in front of the r squared, so we don't have to deal with too much with that. We will in next phases though. Okay, what 2 numbers multiply together to make positive 81? We can go 9 times 9. The only problem is that we want a negative 18. And so maybe we don't want 2 positives. Maybe we want 2 negatives instead. Okay, so remember, you have that option for yourself, just like in the previous phase I mentioned. 2 negatives multiplied together to make a positive. 2 negatives added up will make a negative number. Okay, so your final answer, well, semi-final answer is going to be r minus 9 times r minus 9. You notice that they're both the same factors, and so you're going to go r minus 9 quantity squared. Okay, let's take a look at example number 3 now. This is not a 1 in front of the v squared. Then I'm thinking, can we factor out, can we take out a GCF? And usually for these problems that I'm going to give you, most likely the answer is going to be yes in this case. And most likely, most of the time, sometimes it could be that number in front of the v squared, the coefficient, the a value. So let's see if it works out. And usually, if it doesn't work out, you try a different number. Okay, so let's go and take out that GCF, see what happens. Anyway, let's start with the leftovers first. 2 divided by 2 is 1. I'm going to write that. Plus 20, half of 20 is 10. half of 50 is 25, and because of these reverse distribution arrows, that's signaling me to put that 2 back in front of the in the left side. Okay, I'm just going to block the 2, and now we can do the factoring on this part over here. There's a 1 in front of the v squared. What two numbers multiply to 25? But they got to add up to positive 10. The only pair I can think of is 5 and 5. Okay. 2 v plus 5, v plus 5, and then your final answer is going to be 2 v plus 5 quantity, and then you're just going to put that squared there. Okay, so those are perfect squares for those examples. You know what I like about doing these videos, I keep mentioning this on all of my videos, it's just that, you know, if I'm going too fast, you can hit pause, or if you know how to do all of this, you can skip around. So I think that's what's good about the internet. Okay, all right. Last 3 examples for you guys, and then I want you guys to do some practice problems on your own. Okay, x squared minus 64, and I've written down here, we're missing a middle term. Because usually, I'm going to go back to the last example, usually we have like a square term, a quadratic term, a v, a linear term, just the variable by itself with the coefficient, and then we have a constant or a number, so we have 3, like a trinomial. Okay, we have a trinomial. But in this case over here, we're missing that middle term, and this is one way we could do this, and I'll show you 2 ways to do this. One way is to add possibly a 0x in the middle. So this is one way you could tackle this problem. So let's try that. X squared plus 0x minus 64. And the reason why we're putting a 0 in front is because we don't see any x's over here. There's none, so I'm going to put 0x. When you do that, then you can start thinking about factoring the way that we've been doing so far. There's a 1 in front, and so we can just focus on the negative 64. What two numbers multiply to negative 64? Remember, one has to be positive and the other one has to be negative. Okay, but they need to add up to 0. 0 could be positive or negative. Actually, it's neither positive nor negative. This is not going to work out. I do have a pair in mind, positive 8 and negative 8. A positive times a negative is a negative. 8 plus a negative 8 is 0. And so that is the pair that we're going to use. X plus 8, x minus 8. We are not going to put x plus 8 squared. So, you know, some students are going to write something like this. No, these are not the same. Yeah, these are not the same. So this is your actual answer here. Okay, so you're not going to write it like that because they're not the same. Okay, so these are the same. Okay, x plus 5, oh, v plus 5, v plus 5. So that's why you write the square. Okay, but these are not the same. That's going to be your answer because one is a plus, one is a minus. Okay, so just be careful with that. So that's going to be one way to do this. Okay, I want to show you another way, and some teachers actually teach it this way too as well. You're still going to get the same answer. Another way, this is actually what's called differences of squares. Okay. I'll explain a little bit why they're called differences of squares. Well, I mean, I'll give you one of them. Differences, one reason why differences means minus, so you're subtracting. And so that's why we have that minus sign over there. I'll explain the square a little bit later. Okay. Let's go factor this one first, and then after that I can explain why it's called differences of squares. Really, take a look at your binomial over here. Can you square root the first term? Can you square root term? And is there a minus sign in between? And so you need these 3 things in order to do differences of squares. Okay, so let's go take that first term first, x squared, and if we square root that, square root of x squared is going to be x. Okay, alright, let's go take the 64. Just ignore the negative for now, so let's just take the 64 over here. Can we square root that? Yep, we can square root that. Square root of 64 is going to be 8. And so to factor this, you're going to use this pattern that I have provided for you guys over here. And this pattern is when it's after everything is square rooted. So your final answer for this one is going to be this. X plus 8. And the other one will be x minus 8. And that's it. So either both methods are going to be okay. If you would rather add the 0x inside and then do this method, that is totally fine. If your teacher prefers that you do this method and see that you can square root the first and last term and then there's a minus sign, that's also okay. It depends on which one is going to be faster for you. You're still going to come out to the same answer. I forgot that I have to explain why it's called differences of squares. I'm just going to rewrite this as squares. This is really x squared minus 8 squared. You're subtracting 2 squares. Remember, the area of a square is s squared. S squared minus s squared. You're subtracting 2 squares from each other, area-wise anyway. So that's why it's called differences of squares. Okay, well, I think that was a very long explanation than I had thought. Let's just do the last 2 examples, and then I'll give you guys 6 practice problems for you guys to do. Okay, an example number 5, I'm going to do it the first way, x squared minus 16. I see that I don't have a middle term, so I am going to write a plus 0x minus 16. Now I'm going to focus on the negative 16. What 2 numbers multiply to negative 16, but it's got to add up to 0. And the pair that I can think of is 4 and negative 4. And so your final answer is going to be x plus 4 and then x minus 4. So I have done it the first method that I showed you on differences of on this kind of pattern. X plus 4, x minus 4. I'll do differences of squares on this last example, and I want you guys to do it on your own. First of all, can we take out a GCF? Can we factor a GCF? The answer is yes. Let's see if we can extract a 7 from both of them, from both of these terms. 7 divided by 7 is 1, x squared. 175 divided by 7, I think that 25 quarters, 7 quarters make $1.75. So sometimes I think of it that way, in terms of quarters. Anyway, we still got to put that 7 up front over here. I am going to do the difference of squares method. Hopefully you can see it. Are these 2 terms square rootable? Can you square root both of them? The answer is yes. Square root of x squared is x. How about square root of 25? Well, that's 5. And there's a minus sign. So we can follow that structure of the differences of squares, where we're going to have x plus 5, the term that's already been square rooted, and then the other one will just be x minus 5. So you decide what method you want to do for differences of squares. One could be easier than the other depending on what you like, of course. Alright, let us now practice with a you do. So you do this on your own, pause the video, and then I'll give you the quick answers to follow, and then plus the explanations if you want. X squared plus 16x plus 64, factor that. V squared minus 12v plus 36, 3n squared minus 90n plus 675, k squared minus 9, x squared minus 196, and then, oh boy, whoa, 7m to the 4th minus 847m squared. So pause the video, grab a piece of paper, do this on your own, but I'm still going to roll the video for about maybe 10-15 seconds, and then I'll give you guys the quick answers plus explanation. Okay, hopefully you didn't roll the video, but it's up to you because time is pressing. Maybe you're wanting to study for an exam or a test or so. So here are the quick answers first. Okay, so the answer to x squared plus 16x plus 64 is x plus 8 squared. Okay, for this one over here, it's going to be v minus 6 squared, and for this one here, it's going to be 3 parentheses n minus 15 quantity squared. Okay, the answer to k squared minus 9 is this, k plus 2, k minus 3. This one over here is x plus 14, x minus 14. And then for number 6, it is 7m squared with m plus 11 times m minus 11. Let me leave this up here, and then I'll do the explanations pretty soon. Okay, let me just go and explain. So let's start off with number 1. There's a 1 over here, so really what two numbers multiply to 64? I can only think of 8 and 8. And sometimes there is 2 and something else too. Okay, 32. But sometimes, maybe sometimes the first thing that you think of is probably the correct answer. Okay, so 8 and 8, because they also add up to 16. And so this is going to be x plus 8 times x plus 8. And then you're just going to write this as x plus 8 squared. Okay, number 2. There's a 1 in front. What two numbers multiply to 36? I think of 6 and 6 and 9 and 4. But we want those pairs to add up to negative 12. And they're not adding up yet because they're both positive. So maybe instead of positives, maybe we can have two negatives instead. Negative 6, negative 9, negative 4. This one will be our answer because they add up to negative 12. So it's going to be v minus 6, v minus 6. If you can see that you can just skip down to this step over here, then that's totally cool. That's totally fine. Okay. All right, number 3. Can we do a GCF? And we probably can. We can factor out a 3 at this case. Okay, so let's go see our leftovers. I'm running out of, let me just redo this one over here. Equals, okay, n squared minus 30n, and then let me see if I can grab a calculator of sorts, plus 225. Okay, and then we'll put the 3 back over here. Alright, well, now what two numbers multiply to 225 but add up to negative 30? I have 15 and 15. Why don't these two positive numbers work even though they both multiply to 225? It's because we want a negative number. And so maybe instead of two positives, we can have two negatives instead. And so that's going to give us the answer. Okay, 3, n minus 15, n minus 15. And let's just shorten that to n minus 15 squared on that one. Okay. All right. I'll provide explanations for the last 3, and we are done for today. Okay. Here are the last 3. You can probably already guess that these are going to be differences of squares, but I'll try to do them both ways. Okay. Let me try to do the add 0k on this method. It doesn't matter which method, k squared, I see that we don't have a middle term, and so I'm going to add a 0k minus 9. Okay, well, what two numbers multiply to negative 9 but add up to 0? Some students like to list down negative 9 and 1, 9 and negative 1. That's cool. I immediately think of 3 and negative 3. Remember, for the negative, one has to be positive and one has to be negative. And so we're going to take this answer. They add up to 0. So this is going to be k plus 3 and then k minus 3. Okay. All right. All right. I want to do differences of squares on this one. Well, let's take a look. Can we square root x squared? Yeah, it's going to be x. Ignore the negative for right now, the minus. Well, what's square root of 196? It's 14, okay? And there is a minus sign in between. And so, we can build our factors already. It's going to be x plus 14, and then x minus 14 for your differences of square structure. Okay. You could have also added 0k. It wouldn't, you're still going to come out to the same answers anyway. All right, last one, 6. Let's see if we can definitely GCF step at a time. Let's see if we can GCF. Let's see if we can extract 7 on both of them. Okay. If we do that, our leftover inside this factor is going to be m to the 4th minus. Oh boy. Even teaching math for a while, I still can't do higher numbers. Well, that's what YouTube is for. I saw a YouTube video on that one, so I'm going to have to do that sooner or later. Anyway, 847 divided by 7 is 121. And don't forget the m squared, and also the 7 over here. I can, I could see a couple ways of doing this, I guess, but you know what, this is what I was thinking. Can we also factor out a couple of the variables? And the answer is yes. Okay, so I'm going to show that in green. You have 4 m's over here and you have 2 m's here, so the maximum that we can take out is m squared, 2 m's multiplied together, because this one has 2 maximum m's and this has at least 2 m's, that's 4. Okay, so let's go take those out first. Okay, you have 4 m's and you're taking out 2, then that means you have 2 left over, and then you've already taken out those 2 m's, so now you're left with 121. So now on the right side you have 7, and then the m's that you've taken out, m squared. Okay. Now let's go test to see if this is differences of squares. Square root of m squared is going to be m. Square root of 121 is going to be 11, and there's a minus sign in between. So let's follow the structure of differences of squares. I'm going to write 7m squared first. Shoots, I'm running out of room. So it's going to be m plus 11, not 121, it's the 11. M plus 11, m minus 11. Okay. I will see you guys in phase 4.